In the last class, we have discussed the basic operation of the decoder, and we have realized the 2:4 decoder and the 3:8 decoder also. In case of 2:4 decoder, we have seen how the active high decoder and what is the active low decoder, and we saw the truth table and the logic diagram as well. So now we will discuss some of the problems related to the decoder. So here is the problem. The realization of Boolean expression f1 of x2 x1 x0 which is equal to summation m 1 2 4 5 and f2, the one more equation, x0 x1 x0 is equal to summation m 1 5 7 with a 3:8 line decoder and a 2 OR gate. So in this problem they only specify that what kind of decoder, how many the line decoder we need, that is the 3 input and 8 output line decoder we need, and here they specify that which gate we need to select, OR gate. Now the thing is, we need to decide whether I need to use active high decoder or active low decoder. See, according to the specification, this is by seeing this equation, these two equations are SOP equations, isn't it? So now, and they are given 3:8 line decoder. We don't know whether it is active high or active low, and they have given which gate we need to use, OR gate. Now the beginning basic we learned that if I take active high decoder, so in order to generate the SOP equation, I need to use either AND gate or OR gate. Similarly, using active high decoder, if I want to generate a POS equation, I need to use NAND gate or NOR gate, isn't it? This is active high decoder, active high decoder. Similarly, for active low decoder, if I take active low decoder, if I want to generate a SOP equation, I need to use NAND or NOR gate, and similarly for the SOP equation I need to use OR or AND gate, isn't it? But according to the problem, they have given already, see, this is the SOP equation, and they told that I need to design using OR gate only. This is the OR gate, and obviously this is the SOP equation. Then it is holds good, we need to select an active high decoder rather than the active low decoder. Are you clear how to choose the decoder? In this problem they haven't mentioned which decoder we need to select, but here the right choice is active low decoder, correct? Are you getting? You know this, and this is the equation, is SOP equation. Then you are in a position to decide whether you need to use active low decoder or the active high decoder. Now according to this we need to use active high decoder. Now the problem is solved and we got the solution, like we need to use for this problem active high decoder. In this active high decoder, already they have mentioned how many inputs and how many number of output required. There are 3 input, that is the 3:8 output, 2, 3, 4, 5, 6, 7 and the 8 output, x0, x1 and the x2. Outputs are y0, y1, y2, y3, y4, y5, y6, y7, and I need to design a 3:8 active high decoder. Even as soon as we are seeing, this indicates active high decoder. Active low decoder means what? Output contain a bubble. Now we need to realize these two expression. So first one is f1 of x2 x1 x0 which is equal to summation 1 2 4 5. So I will use one OR gate because they have mentioned already, and which are all the get connected for this OR gate is, this is for first function 1 2 4 5, 1 2 4 and the 5. Similarly, if I want to design one more equation, that is f2, that contain f2 which is 1 5 7, that is 1 5 and the 7. See, this is how we can possible to solve the given decoder problem. This is one more problem, second problem related to the decoder. The given problem is realize f equal to pi m 1357 using 3:8 active high decoder. Here the which decoder we need to use, they have already specified in the problem, active high decoder. So which is the active high decoder? This is the active high decoder. And what is this? This is the pause equation. If I want to design a pause equation, which gate I need to use? So the one thing is clear is we need to use active high decoder. Now this is the pause equation. In order to generate the pause equation, which gate I need to use? Either I can use NAND gate or the NOR gate. Are you clear? So now we got the solution. For in order to realize this equation, we need a NAND gate, because this is the pause equation. In case of active high decoder, if I want to design a pause equation, then I need to use a NAND gate. Okay, now I will construct a 3:8 decoder. 3:8 decoder. Here X0, X1 and the X2. Here we have Y0, Y1, Y2, Y3, Y4, Y5, Y6 and the Y7. These are the outputs. With respect to that output, so which gate we need here? A NAND gate. I am using NAND gate in the output stage. This is the NAND gate for the equation. Which are all the lines get connected? 1, 3, 5, 7. 1, 3, 5, 7. In the output stage we are getting M1 plus M3, sorry, M1 into M5 into M7. This is what we are getting with the help of the NAND gate structure. This one already we discussed how it will generate the pause equation. Now we will see one more problem, third problem. Implement the following equation using active high 3:8 decoder and get the pause and the stop equation. So this is the given equation is the pause equation. So now it is very easy to generate this equation, not a problem. So now only we need to bother how to generate the stop equation. So now we have, this is the active high decoder, 3:8 active high decoder. So with the help of active high decoder, if I want to generate a pause equation, which gate I need to use? Either I need to use a NAND gate or the NOR gate. So now I will use the NAND gate. So for the first equation, so first equation which are 0, 1, 3, 5, 0, 1, 3 and the 5. So this is for first equation, F1. That is, we are getting M0 into M1 into M3 into M5. Similarly, to realize one more equation, one more NAND gate we required. So that one is 1, 3, 6, 7, 1, 3, 6 and the 7. F2 will be M1, M3, M6, M7. So this is. Now the challenge is how to design a SOP equation for the same pause equation. Now in order to realize the SOP equation, so X0, X1, X2 and the output is Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, that is the 3:8 decoder. Here what we need to do is, so whichever the term not present in the first equation, you see that 0, 1, 3, 5 is present. Which are all the terms left in case of 3:8? So here 0 is there, 1 is there, 2 not there, 2 is not there, 4 not there, 5 is there, 6 not there, 7 not there. So that should become for the first pause equation, that is summation of m contain 2, 4, 6, 7. The term one which not present, so that and all comes under the SOP. Similarly, in this case, second equation also, whichever the terms is not comes across, this is for F1 realization. In this case, 0 is not there. So whichever the term is not there, that is belongs to SOP. 0 not there, 2 not there, 4 not there, 5 not there. So that is comes under for second function. So with the help of this function, we will realize. For in order to generate the SOP equation using active high decoder, which gate I need to use? I need to use either AND gate or the OR gate. So here I will use AND gate to implement the above function for the F1. So Y2, Y4, 6 and the 7. Similarly for the F2, 0, I need to take 0, 2, 4 and the 7. Sorry, 4 and the 5. So this is how we can possible to solve both POS and SOP equation for the given problem. This is fourth problem. Now we will realize a function f equal to pi m of 1, 3, 5, 7 using 3:8 active low decoder. See, using active low decoder, I want to realize the POS equation. This is the active low decoder. If I want to realize the POS equation, obviously I need to use an AND gate. So straight away here I will use an AND gate. This is the F. Then 1, 3, 5 and the 7 get connected. Finally I will get M1, M3, M5, M7. This is the solution for the given problem. This is the fifth problem. Here realize the following equation using active low decoder. Function is f equal to summation m 1, 2, 5, 7. Here we know that what kind of decoder we need, active low decoder we need, and it is for according to the function we know that we need a 3:8 decoder, and here the challenge is what type of gate I need here. So this is the active low decoder, yes, and what is the equation type is? This is the SOP equation, and which gate I need to use? NAND gate. This is the solution, is the NAND gate. So then I will use straight away here the NAND gate in order to realize the following function. I hope you all getting how we are selecting the gate output gates. So 1 is get connected over here, 2 get connects 5 and the 7. This is the function which is M1, which is M1 plus M2 plus M5 plus M7. Now we will focus one more problem. Realize following function using 3:8 decoder. The 3:8 decoder they only specify, and these are the two functions. These two functions we need to realize using AND gate, and these two functions we need to realize using NAND gate. In this case, these two functions, if I want to realize with the help of AND gate, so what type of equation? It is a POS equation. So here the challenge is what kind of decoder we need, whether we need an active high decoder or the active low decoder. For example, this is the POS equation. This POS equation I need to realize with the AND gate. So then where the POS here? POS. So here NAND and NOR is there, not possible. Now we will come to here POS. So in order to realize this POS equation using AND gate, so then which decoder we need? We need an active low decoder. So for the first case, if I want to realize these two functions using AND gate, so I need here active low decoder. Okay, so these two are the POS equation. So this POS equation they are telling I need to design AND gate, so then I need to use active low decoder. Then here I will use active low decoder. Three is to 8 active low decoder, X0, X1 and X2. This is the 3:8 active low decoder, and it had Y0, Y1, Y2, Y3, Y4, Y5, Y6 and the Y7. There were 8 outputs. Then this get connected. The first function, if I want to realize the first function using an AND gate, here I am realizing using AND gate the F1, 1357 1 3 5 and the 7. Similarly, if I want to design the second function F2 2 3 4 6 2 3 4 and 6. This is using AND gate. Similarly, if I want to design same Boolean function, two function using NAND. Again, using NAND gate, I need to design a pos equation. Then the pos using NAND, so here pos, NAND is not there. Now I will go and see here. So using pos, for the pos equation, I can possible to realize the NAND using NAND gate. And what is the decoder type is active high decoder. For this case, I need active decoder. This is the other way. In the previous problem, they are going to be specifying whether we need to use active high decoder or the active low decoder. But in this case, they specify the gate, AND gate and the NAND gate. With respect to that, we need to decide whether we are using active low decoder or the active high decoder. So in this case, I am using active high decoder. In this case, again I will take 13:8 decoder, active high decoder, and it had 8 output, Y0, Y1, Y2, Y3, Y4, Y5, Y6 and the Y7, X0, X1 and the X2. In the output state, first I will take one NAND gate. For that NAND gate, for the function 1357 1 3 5 and the 7. Similarly, for the second function, one more NAND gate, that is F2, that is 2 3 4 6 2 3 4 and 6. So this is how we can able to realize any Boolean equation with the help of decoder. Now we will see one more problem related to the decoder. So realize the following equation using 3:8 decoder with the minimum number of inputs f equal to pi m 0 2 3 5 7. This is straight away I can tell this is the pos. But here one more constraints I got. I need to design with a minimum number of inputs. So then the solution is, so instead of that, if I realize same thing with the help of SOP, there may be a chance of getting the less number of inputs. So same equation, if I want to convert into a SOP form, then f is equal to summation of m. So whichever the term is not there here, that term comes into the SOP. So then it is 1, 4 and the 6. Obviously, compared to this, which is having a minimum number of inputs, straight away I shouldn't use this pos. This pos I need to convert into SOP. Then I am getting f equal to summation m 1, 4, 6, which contains minimum number of inputs. Now the challenge is whether I need to use active high decoder or the active low decoder. This is basically a SOP equation. In order to design any SOP equation, the active high decoder is the preferable. So then I will take, my selection is active high decoder. So once I select the active high decoder, I need to decide what kind of gate I need at the output stage. So this is a new SOP equation. Once I select active high decoder, in order to realize the SOP function, I can use AND gate or the OR gate. So here the selection of gate is AND gate. Then I am going to be designing this. So again it is a 3:8 decoder, active high decoder. Again it had 3 input and 8 outputs, Y0, Y1, Y2, Y3, Y4, Y5, Y6 and the Y7. And here in the output stage I am using one AND gate. This is the AND gate, and 1, 4 and 6. This is how we can possible to realize a decoder, 3:8 decoder with minimum number of inputs. And this is X0, X1 and X2. The next class we will discuss the decoder with enable input.